Thank you, everybody, for sort of returning to your seats and settling in for our next session. Before I introduce that next session, I had an opportunity to connect with our interpreters, and I just want to put a special thanks out. I don't know if you all know this, but we are interpreting in Spanish to a remote audience and also within the room. And I'm always so amazed that people are able to do that in real time to interpret. And I want to point out that Ruth, Carlos, Grizel, and Andrew from TransLab very much appreciate you guys. So thank you. Let's give them a hand. Okay, so at this point, I'm going to turn it over to Denise Kennedy, President of DK Enterprises, to facilitate this panel. Thank you, Denise.
All right, you guys, so we went back up. All right, so I'm going to first of all tell you a little bit about what we are going to do on this, and then we're going to do introductions after that time. But you can see their names and you can see it on the screen, but we'll do that in a minute. What we want to do here, and I do want to say this, there is 160 years of experience between all of us sitting here today, which is a lot in tire recycling and the tire industry. So I want to say that this session is, when we call it the tire industry, since the USTMA and the Tire Industry Tire Association, we're now forming this new association called the Tire Recycling Foundation. It's one great big industry. It's the first time that you have this sense that we're all going to work together more than ever. Not that it hasn't happened some, but now it's happening. So for the purpose of this session, the tire industry is going to be the tire manufacturers, the tire-derived product manufacturers, and then it's also going to be your feedstock suppliers. So that's sort of the central part of this particular one. We want to be able to show that our users are able to look at your PCRs. You had that session yesterday, session 3. Look at that. I think it's really important. That's why we added it to this conference. And you can't have an LCA or a EPD, all these terms, without that. So all of these things that we're talking about in this conference are important and do show up a little bit in what we're going to do today. We really do believe as an industry, we are revolutionizing the road through sustainable and innovative practices. We want to show that as in our conversations today and what we're trying to do to make changes. We understand that the new tire manufacturers, when Bridgestone and Michelin have combined and really gone out there and said, by 2050, you know, we were going to have our tires be sustainable, has made a big difference. And it's kind of forcing the issue and the discussions and the circularity. Michelin's goal is 40% of their tires are to be comprised of renewable and recycled materials by 2030, sorry, that's 2030. Everything has to be sustainable by 2050. Bridgestone is committed to carbon neutrality and is exploring renewable energy and improving the production energy efficiency. And then Pirelli, it has a goal of achieving 100% renewable electricity worldwide by 2025. So they all have different goals and objectives, but it's kind of driving it into one initiative or one goal. Some of these initiatives do include, which we're going to talk about today, eco-friendly materials, the raw material sourcing, energy efficient manufacturing, production processes, and the end-of-life tire management. That's why we are now a tire industry. And I want to add one thing. As a tire recycler for years, we would love it if the new tire manufacturers would support taking some of the products that we make and putting it in some of your thousands upon thousands of stores. So I just want to say that if we're all going to get together, we would love to see that. Okay, so we have about 8 big questions, 8 questions, and then some solutions. And some of this is going to be a little bit technical, but I think it's the intent to do this is to be informational. And I think that we don't always get to hear some of the things that our experts are going to talk about. So starting with me, we're going to do introductions. I'm Denise Kennedy. I've been in this 36 years. I have started by running plants for years. I went out on my own in 2005, became a contractor with CalRecycle, had 12 contracts as a subcontractor and contractor, and I'm very involved with ASTM. I chair rubber recycling. I am a chair in Recover Carbon Black for environment safety and sustainability, and I'm working with David Parker, who's the chair of devulcanization, and I do playgrounds and sports fields, but mostly the first three. That's why I'm around everybody all the time and love this stuff. Okay, now, this is Eric Sharp.
Yes,
Talk louder, I think.
I'm Eric Sharp, ACE Laboratories. We're an independent test lab. We support the polymer industry as well as construction materials, and we have an analytical lab in addition to that. Been in the polymer industry for 22 years, all in technical roles. Also on the executive board for the American Chemical Society Rubber Division and the advisory board for the Youngstown State STEM College.
Thank you. Brendan Rogers.
My name's Brendan Rogers. Where do I start? I've been with Goodyear for about 25 years. Worked in Northern Ireland, which is where I'm from. I was born there, raised in Canada, but worked in Northern Ireland. And spent a few years in Luxembourg working on high-performance passenger tires. And then I got transferred to Akron, where I was 17 years in Akron. And I was the chief engineer for truck tires, aircraft, farm, and OTR tires. In 2002, got a chance to move to ExxonMobil and to Baytown, east side of Houston, at the refinery there. I was 4 years in Baytown, and then I got assigned to the Saudi Arabia government project to design a downstream industry for the ExxonMobil plants that have been built in the kingdom. Spent 3.5 years in China after that, working at the ExxonMobil R&D center in Shanghai. And then when I came back, I was exhausted, so I quit. So that's a snapshot.
Okay, Chris Robertson.
Hi, I'm Chris Robertson, and I would probably call myself a materials scientist, and I spend most of my career in R&D either at tire companies, Bridgestone and Cooper Tire, or at raw material suppliers to tire companies. So I've seen both sides of that, especially around what it takes to take a new raw material and get it into proofing it and taking a look at it in the lab, scaling up, and that whole side of the business. And so nowadays, for the last 3 years almost, I started my own business. So I've been doing consulting, and my connection to sustainability is through now my clients. And one of my main clients that I've been working with for over 4 years now, I actually started working with them before I went on my own, and is Monolith, and they have a new process for making carbon black, and it's not sustainable in the traditional sense, but it's very low CO2 compared to traditional carbon black, 90% reduction in CO2 compared to traditional carbon black. My other connection to sustainability is one of my clients is a top tire company, and they're faced with the same challenges the whole industry is they all have targets for a certain percentage of sustainable content, so they're always trying to figure out how to do that but maintain performance. And at the same time, they're also faced with the challenge that folks were talking about yesterday. The loss of the multifunctional stabilizer 6-PPD is really something they're facing, and so I help them on both fronts there. And then finally, I recently got involved with a startup company, and they need help with sort of market development and doing some value propositions for a new kind of source of natural rubber, which is from the leaves of sunflowers. And so that's an interesting new topic. We'll talk about about natural rubber from alternate sources later. That's a new one that's coming on that I've recently got involved with. So that's some of my connection to the sustainability front.
Thank you. And then David Parker.
Yes, my background is trying to find technical enablements to solve industrial problems. That's what I've done for the last 25 years. So chemists that are a lot brighter than me started a business with me. It's called New Rubber Technologies, focused on trying to see if we could take what I'll call end of first life waste material and repurpose it in a number of different applications to accomplish what was described yesterday as either open loop or closed loop recycling.
Okay, thank you. All right, so here we go. I'm going to ask, some of you know which questions, and if you feel we've missed something, then be sure and add it, but we only have now about 35 minutes before we start having to go into other questions, so, and we have a lot. This first question is going to be for Chris. We know that tires are made from natural rubber, synthetic rubber polymers, I should say, carbon black, silica, steel and textile cords, antioxidants, anti-zonates, and I didn't say that right, I don't think, resins and oils. And so with Chris, what I want to ask you is, what are some of the other changes that we're seeing to natural rubber, to replace natural rubber when there's concern sometimes if we're going to have enough? So if you could take that on and talk about the items that we mentioned.
Sure. There's a lot of moving parts when it comes to natural rubber. The first is those targets that the tire companies have set. One way to reach it is by increasing the amount of natural rubber in tires. Natural rubber is coming from trees, and so one of the ways to get more sustainable content is just to increase the amount of natural versus synthetic rubber. So that's a higher demand, and demand was already starting to exceed supply of natural rubber globally. And so part of the look at alternatives is just a realization that we're going to need more, and we might not have enough in Hevea, which is the tree in Southeast Asia where most of the natural rubber comes from. And so folks are starting to look at alternatives. The other reason people are looking at alternatives is because of fear that disease could wipe out the supply. And the reason why they're so concerned about that is because it actually happened before. It used to be we got most of our natural rubber from Brazil. In fact, the species of natural rubber we use now is called Hevea brasiliensis, and from Brazil. And so it started there, and most of the supply was there, but then a leaf blight wiped it out. Disease wiped out the supply. It has since recovered slowly. But before that happened, the plants had been transplanted to Southeast Asia. So the plants that are growing in Southeast Asia, Malaysia, Thailand, India, all of those places we get natural rubber from, the species is the same as the one that got wiped out. And so that's the concern, is a fear that that could happen again. And if it did, it would be, natural rubber is a strategic raw material, and it would cause lots of problems. And then there's the geopolitical part, which is, if it got cut off again like it did in World War II, what would happen? And so that's sort of the driver. And so there's two main candidates. One is Waiuli, which is a kind of a brush-like plant. They extract it from that. And the other one that's coming on is dandelion natural rubber. Not the ones that you try to kill in your yard, but a different version. And most of the natural rubber is actually in the roots of that. In terms of what progress is being made, at this point, demonstrations have been made. Cooper had a project with the USDA, and they demonstrated and made a tire out of Waiuli rubber. And on the dandelion front, Continental actually makes bicycle tires. If you search Continental dandelion bicycle tire, they have brought to market at least a bicycle tire made of dandelion rubber. However, the volumes are very small still, and it's still developing, but there's a lot of interest and it's growing. What's kind of limiting it, I think, is we haven't had the geopolitical problem, and we haven't had the disease issue. So it's this, this mysterious monster that's waiting, but it's not here yet. And so people are kind of worried, and it's all about risk management. We need a source, a domestic source in particular. But the catastrophic event that would trigger the growth of that industry and the funding and everything hasn't quite been there yet. The only other thing I'll say about natural rubber,
We got to go to a next one here. We're never going to get through them all, too. So
Okay.
is it real short?
no, just
Can I move
with the
on?
growing natural rubber amount in tires, that's the material that needs 6 ppd the most. So we have this sort of collision of things happening, more natural rubber and no more 6 ppd. And I just wanted to throw that out there because that is something I want people to start thinking about.
And there is a difference. We're talking to scientists here who really know their stuff. So just, we got a whole lot of questions, but that was very good, so thank you. Because we have 4 different materials we want to talk about really quick before we get to the next layer. Another one is silica is an issue. We just took 4 of these. Silica is a compound that is recognized for its many benefits, including 15% enhancing safety performance when it's wet outside. And Chris, I'm going to ask you again, just for a second, because I want to turn this over to Eric. What are the other benefits that go along with silica when you take a tire?
Yeah, you mentioned wet traction. The big one is rolling resistance. So about 10% of the gas you put in your car is to just overcome the viscoelastic resistance of your tires, just to get them going. And so there's a lot of opportunity to improve the fuel economy. And silica, compared to carbon black, can reduce about 30%. So you get about 20 to 30% better gas mileage with silica in the tread than you do with carbon black. I would say that's the main one besides the wet traction.
Okay, thank you. And then Eric, you said that and Eric has a lab and he's everywhere with tires all the time. What other recycle and reclaim silicas that are in development? You said there were 4 of them.
Yeah, there's different technologies out there available. That is the advantage being an independent lab, is a lot of times we're screening new technologies before they become commercial. So for me, being a nerd, that's kind of exciting to see what's out there. On the silica front, there's 4 that we've kind of seen growing, a couple of them a little more commercial than others. You got rice husk that's out there as a commercial alternative to silica. That's a valid option that we've seen decent performance on, but there is very limited supply available for something like that. There's carbonized soybean oil, which is kind of an intermediate between silica and carbon black when it comes to performance. You don't get as much as the rolling resistance advantages as you do with traditional silicas, but it does kind of fall in between a silica and a carbon black. Where I've seen some exciting involvement, and it's all still on the pilot scale, is on the recycling aspect of creating precipitated silica. And 2 main sources for that, one being steel mill dust and the other one being coal fly ash. Both of those waste streams have very high content of silica, and there's been very good advancements in being able to extract the silica from those waste streams. And then after extraction, you can take it through the precipitation process to make precipitated silica. We've worked with various clients that have done this on the lab scale, pilot scale, and once you've got it extracted and you go to that precipitation process, it's all down to generalized technology of creating precipitated silica at that point. So you can modify the surface area, your treatment, all of that to be very similar. That concept can go across the board, though. Any waste stream that has a high silica content, that can be applied to, being able to extract out the silica and then go through that type of process. The main thing that needs to happen at this point is just more adoption to be able to get that scale to ramp it up. Every time I see that there's a silica plant expansion with traditional technology, kind of makes me irritated of knowing that there is the option where we could be using alternative feedstocks like this to be doing the same thing.
Okay. Another one is going to be carbon black. Now, we're going to talk about recovered carbon black a little bit later. And Chris, I'm going to ask you what other sustainable carbon blacks, in a short version.
Sure, yeah. The one I mentioned earlier, Monolith, has an alternative. It's not, it's still using a fossil fuel of natural gas, but because they do the plasma process in low oxygen, they make a lot less CO2. And so it's in that intermediate zone of being better for a lot better for the environment, but not fit that strict definition that some are using for sustainable materials. But that's coming online, and they have partnerships, and there have been press releases out. They're in tires now commercially, and so that's pyrolysis carbon black. The other area is, and you're going to hear, plasma carbon black, and you're going to hear later the recovered carbon. That process of making it is pyrolysis in low oxygen environment. People are doing the same thing with biomass waste. They're taking corn cobs and those kinds of stalks and other waste streams, coconut shells, and they're pyrolyzing them in a low oxygen environment and making a carbon-like filler that then could be used. So you're going to see more of biomass waste being turned into fillers, and some of those are carbon-based fillers.
Thank you. Okay, so both PAHs, which is an organic compound made of carbon and hydrogen atoms, is known for its stability and for its persistence. And then phthalate regulations are driving the tire industry away from the traditional hydrocarbon process oils. So I'm going to ask either Chris or Eric to take this one on to talk about what are the bio-based alternatives that are gaining the most traction right now.
Yeah, I can quickly talk to that. You know, as you mentioned, the PAH and the phthalate requirements that are out there, there's a lot of more restrictions on typical aromatic type oils, as opposed to that, as a result of that. So you're seeing movement for alternatives. Obviously, bio-based is a big movement because you can kind of get twofold of getting away from the regulatory requirements and also utilizing recycled or sustainable materials with that. So we've seen a lot of advancements already being used commercially out there by the tire companies, or things like soybean oil that you're seeing a lot of movement on. TDAE, which is still an aromatic piece, but it has the extract of that, which really reduces the regulatory piece of it. Items like rapeseed oil we've seen perform really well as in that area too. The only concern that I have is, right now, those work economically. When you do compete with food sources, though, you always run the risk of, depending upon food supply and things like that, food is always going to pay more than what polymer industry or our type of market will. So if it gets tight ever, competing with food is never a good position to be in. So it's the only thing to weigh with that, but there have been a lot of good advances with the plant-based oils that are out there.
And Chris, too, are you seeing these different alternatives being used in the tire makeups as well?
Yeah, absolutely. There are commercial tires on the road that have sunflower oil in them, that have soybean oil. There have been press releases by various companies, and without a doubt. The only thing I would add to the list that Eric nicely covered is there is farnesene is a molecule that can be, beta-farnesene can come from sugar, and you can polymerize it into a polymer, but right now they're low molecular weight. So they're not big molecules like the polymers that we use, the elastomers, but they're in that processing kind of improvement range. So polyfarnesene, but oligomeric is out there, and that's coming from sugar. And the other one is natural rubber. You can use it as a high molecular weight version as an elastomer, but you can also depolymerize it into a liquid natural rubber. And some people are starting to look at that. You can do it in the latex. You have to oxidize it somehow with UV or temperature and oxygen, but you can do it. You basically break the big spaghetti down into little short pieces. And then those pieces act kind of like the oils do. They help you with the mixing, but they're long enough that when you vulcanize the rubber, they cure in. So then the oil doesn't bleed like an oil will and doesn't move around the compound. So that's the case where there's a performance advantage as well as a sustainability aspect.
I'm going to interject one thing here. And as involved as I am in ASTM, as these changes are occurring, we're even finding it in our classification standard, which is D5603. We have something on ash that's in there. As these changes are being made, the standards have to reflect changes. So we have gone back now to have that done by another committee. But I'm just saying, as you hear all these things, just realize it's going to change some of your manufacturing processes too. But I think it's important to just be aware of these things are happening. Okay, so we're going to go really quickly into environmental. And my first question and probably the second question are going to be more toward Brandon. So capturing CO2, which we all hear about all the time, is known as a carbon capture or storage, and it involves a series of processes aimed at reducing the amount of carbon dioxide, CO2, released into the atmosphere, therefore mitigating greenhouse gas and combating climate change. So I'm going to ask Brendan, is CO2 capture feasible in the tire industry? Do you see this happening? And what is the industry doing with regard to carbon capture?
Yeah, that's a good question. CO2, the way we look at it very much is society is demanding almost that CO2 is captured, mitigated by some means or other. So that's an expectation from society. So what's happening is probably a lot more going on with carbon capture than a lot of us realize. And along the Gulf Coast particularly, the oil companies like Exxon and Chevron have got fairly advanced programs underway for carbon capture. So the pipeline network is already built. It's running along the Gulf Coast states, and they're pulling in around 5 million tons of carbon dioxide at the moment. That's currently where we're at, where they are at. And again, this is public domain. The 5 million tons of carbon dioxide that's been pulled off per year is equivalent to around 2 million cars coming off the road. So that's huge. With the pipeline network that's being in place, they'll have the capacity to pull in around 100 million tons of carbon dioxide. And then Chevron around 2030 will be around 25 million tons. So that's in place. That's what's happening. That's current. When it comes specifically to tire factories, there's not much CO2 and relative to what's coming off a petrochemical plant. There's not much CO2 coming off, relatively speaking. I think the big thing with tire plants is going to be VOCs. What are we going to do with VOCs? The EPA could start looking at VOC emissions from the tire plants in 2026 onwards. So we can expect that to be coming. So how do we collect those VOCs or mitigate VOC emissions from tire factories? I think conventional scrubbers and injecting the wastewater into deep wells is going to be not an option going forward. So we'll have to have some sort of infrastructure in place to collect the VOCs. And then inevitably that could end up going into the CO2 stream that's collected. And the oil companies have taken the lead on this so far. I think the biggest challenge looking forward is what we're going to do with all that CO2 when it's collected. Now, it's easy to take it and put it into deep wells in West Texas, which is what they're doing. That's helping with the fracking, shale oil, and so on. So there's a lot of benefits in collecting that CO2. So there's a use for it. But up to a point, we're going to have to find other uses for that CO2. And that should be relatively easy. If we can take CO2 and convert it to methane or ethane, then the petrochemical industry can do a lot of things with, particularly ethane. You can do a lot of things with ethane, or methane. But it's getting to that point, and that's going to be more than likely, inevitably, a biochemical process rather than a more traditional catalytic conversion. Trees convert carbon dioxide to oxygen every day, every night. So the science is there, the biochemistry is there. It's how do we tap into that enzyme technology to convert the CO2 to another usable form. So it's certainly doable. It's going to take some research, but we'll get there. I'm confident we'll get there.
Okay, thank you. Thank you. We got more. If we have time at the end, we can go back on some of these. So where Chris brought up 6-PPD in the beginning, I know that they also this group thought it was important, a couple of them, to at least bring this up again, how it's mixed in with the tire, how it is used. It doesn't mean we understand it's all being looked at. It's probably not going to be there anymore. But Chris, did you want to add one more thing to that? Or do you think you said it in the beginning?
Now, just the interplay between the sustainability push and 6-PPD, I think is something people haven't thought about. And the other aspect is I see a lot of movement for folks coming out with hydrogenated grades of synthetic rubbers. And that's really aimed at trying to make a more saturated polymer that's less sensitive to to the effects of ozone and oxidation. So it wouldn't need as much protection. And those, unfortunately, are all synthetic rubbers. And that kind of opposes the sustainability push. And so there is that kind of dynamic going on. EPDM, people are starting to look at more EPDM in tires because it is a mostly saturated material. It doesn't really need protection by something like a 6 ppd. But again, that's more expensive, and it's synthetic, not natural.
And this is off topic here. Windshield wipers also have 6 ppd quinone. What are those made of? Aren't they EPDM or virgin rubber? I don't know. But anyway, they're full of it too.
Multiple
Yeah.
types of windshield wipers. Some are natural rubber. Those are the ones that we
Yeah,
have.
so it's going to be everywhere anyway. Okay. Did you want to add anything, Eric? I think we've covered enough on that and keep going. Are you okay with that? Okay. Brandon, one of your expertise, or one of many, is actually talking about water conservation, energy, you're about safety, you have all these sustainability things that you look at in operations. So I'm actually asking you you can cover all 6, take the top 6, because it kind of fits together, the 3 and the next one. Do you have some points you'd like to make on that?
Yeah, okay. Yeah, sustainability and the tire industry. I think there's a lot to be learned from the oil and gas industry when it comes to sustainability. So when you look at what they do in a refinery, things like our petrochemical plant, there's probably about 6 key elements there. One would be safety. We have power conservation, water conservation, which is huge, emissions, recycling when it comes to a tire factory, and then the social impact of a facility. But if you look at, I've always been struck by the aspect of safety because when you have a safety culture in a company, it doesn't extend just to the employees, but equipment has to be kept maintained. It has to be operated safely. When equipment is operated safely and within specification, the quality of the products coming out of the manufacturing plant improve a lot. So it has a knock-on effect of the safety culture having an impact on the quality of the products coming out of the factory because the equipment is running better, better quality. They run more efficiently, so the power consumption is less. When it comes to water, certainly the tire industry has been a very broad demand on water, and some companies are very water intensive. Other companies use less water. If we look at the water consumption of the makeup water per ton of finished product coming out of the plant, there's a huge spread in the amount of makeup water. Where is all that water coming from? Well, our word's been used as steam lines, leaky steam lines. You don't see so much of that now, but to go back a decade or so, 2 decades, certainly leaks was always a problem. But cooling water is probably the biggest one from extrusion lines, calendering lines, and that sort of thing. The extrusion lines were used a lot. That water, recycling that water rather than letting it go into the waste stream, there's been a lot of progress there. So I think looking at the last 10 years, 15 years, the water consumption in tire factories has certainly decreased in terms of makeup water per ton of finished product. That has come down. We still have a way to go. So recycling that water rather than let it go into the municipal waste streams is a work in progress. There's more to do there. But I think water is probably going to be the big one that needs to be addressed, as certainly in the United States and in the South as it's concerned. Emissions, I think you can't look at water just in isolation of power and other factors under the pollution umbrella. But the EPA looks like they will be starting to look at tire emissions, tire factory emissions. And then I think that's probably going to be the next big one as well, in addition to water. What about emissions? And we can't continue to use water-based scrubbers and just inject that into the well, into deep water wells. That's going to have to be recycled in some form or other.
I do think there's more and more discussions on tire emissions all the time. There was a conference just a month ago down in Irvine, California, and I think CalRecycle is kind of aware of a lot of that too. So it's more and more activity. Joaquin works with emissions and particle size. And so we have a lot of experts right here in California on that too. Just want to throw that out there. Okay, so our next one is, and I do want this to be about the tire recyclers too, because what the manufacturers are going through, some of you recyclers, unfortunately, it all takes money. That's the one issue that everybody has. So that's why we have to really kind of work together. And when they're changing the tires, we got to remember the people that are actually trying to handle these tires all these years without that kind of support. So that's important. It really is. Okay. Let's see, we did that one. So do you have any recommendations for the tire recycling facilities on what might be needed to meet environmental and/or regulatory requirements now or in the future? You taking
Who's that directed at me?
Whoever would like that one. That one's an open, that's my one.
Yeah,
one.
I think recycling has a role to play. Just for context, with respect to ELTs or end of first life materials, certainly the plurality, and depending on whose statistics you believe, perhaps the majority of reuse today is TDF. California is an exception and has led the way on trying to reduce that, but there have to be alternative methods, and there are. Devulcanization, which is a technology which allows material to be reused a second time in some of the same applications from which that material came. That technology base has come a long way in the last decade. And there's also a recognition that it's not just about the devulcanization technology, it's about the reformulation capability that needs to go with that to hand the material back into the consumers in a form in which they recognize it, and to purposely reformulate for the multiple different applications that are out there for end of life or end of first life rubber. And there are multiple different applications that are out there, some of which are well underway and some of which are just at the inception of their commercialization, but are very, very significant in terms of their potential size and could play a very significant role in the problem from a holistic perspective.
Okay, well, that's going to lead in just because I want to make sure we have time for the next two. So I'm going to ask you, David, on, and then maybe Eric a little bit too on this. We're going to talk a little bit about devulcanized rubber for a minute. There are different types of devulcanized rubber, and I'm asking David to give the short version of what devulcanized is, and then maybe talk about just briefly each of the four main categories of devulcanized rubber, because we are starting to look at that in rubber asphalt now. A lot more effort. We have people here that are involved in it, and David's also very much a part of it.
Yeah, so devulcanized rubber very simply just means rubber where the crosslinks have been broken so that it is more analogous to virgin rubber. Just for those of you in the room that perhaps a little less familiar with it, plastic is a solid when it's below its glass transitioning temperature. Rubber needs to be cured to become a solid. So to return it back into that super viscous liquid state, you've got to break these curing bonds. That is what's meant by devulcanization. Rather than talking about the various ways to do it, because there are many, I think the more important piece is how good is it, which means how well is the material being devulcanized, how many of those bonds have been broken is what it really comes down to, number one, and number two, how cost effectively can that be done? And that's where different methods come into play. It's maximizing properties at least cost. That's the trade-off. And I just quickly comment on some of the discussion yesterday where there was a lot of talk about tires going offshore. A lot of that goes into an alternate method of recycling that's predominant in China and India, which is called rubber reclaiming. And yes, they break bonds too, the cross-link bonds, but they also break the carbon backbone and render the material technically inferior, but still sufficient for many applications, and as such, reclaimed rubber is used in significant volume offshore and then imported in the products that we buy here in North America. The process of reclaim is illegal to conduct in North America and Europe because of the nasty chemistry. Devulcanization is an alternate which does not have any of that nasty chemistry and can be conducted onshore, can provide a locally secure source of materials available for a number of different applications and applications beyond rubber replacement. Denise mentioned asphalt modification, plastic modification, impact resistance, colorants, et cetera, et cetera. Lots of different applications, including going into thermoplastic elastomers that are made a different way rather than made catalytically in a petrochemical plant. They can be made by combining various kinds of plastics with devulcanized rubber.
And I know Eric does a lot of testing on that as well, so I want to, he's like into everything. So so in the end, if you have questions about any of the testing side, for sure. Okay. I do want to also then ask, David, you are the chair of devulcanization. You could briefly say how we are addressing doing classifications. We went through this already for rubber recycling and particle size. So we've done that. Now they're doing it in devulc. They're doing it in recovered carbon black. But you want to say anything about that?
Yeah, I would just say that, again, the idea is to speak the language of the customer. Now, this really relates to the rubber industry as opposed to some of these alternate, equally as large applications in my mind. But within the rubber industry, compounders or vertically integrated manufacturers that have their own mixing operations speak a certain way. They measure things a certain way, their physical properties that they'd like to know about. So we're looking to make at least the triage, if you will, easier by categorizing materials in a category that relates to an intersection of the physical properties that the material has, which is most important to the chemists, and cross-referencing that to the content of recycled material that is in that compound.
Okay. We only have 10 minutes left, so I'm going to take the last topic, I think. And then we missed about 5 questions, but we're moving along. I want to talk about recovered carbon black. Michelin mentioned it, and I want to, because I am in that as well, on ASTM. In 2022, Michelin and Bridgestone put out a paper jointly making a position on recovered carbon black, on increasing the use of recovered carbon black and putting it back into tires. And when I was at Pirelli Tour at the USTMA's conference a couple of weeks ago, we went to Pirelli. And what was neat for me is one of the guys that was walking around on the tour said, oh, that tire has RCB in one of the liners. And we didn't ask him. He just volunteered it. So it was important to them that this effort is being done as well. So I just want to say that. I am asking Brendan to give the definition of RCB, because I could talk about it for a while. So.
Okay, recovered carbon black, recycled carbon black, recovered carbon black. What is it? It's basically, I guess, tires that have been gone through a pyrolysis process, oxygen starved, so they get carbon rather than carbon dioxide. The heating in the reactor occurs around 300 degrees to 500 degrees centigrade, depending on the process. And so we get a product. The benefits that Michelin and Bridgestone have claimed in their joint communique has been reduced reliance on petrochemicals as other raw materials, and then the impact on CO2 emissions. So that's what they, that's what the press release indicated was their objectives and benefits. I think maybe
go ahead. No, go ahead.
Again, there's probably a lot more going on here than we a lot of us know. Continental Carbon in Houston is converting one of their carbon black plants to recycled carbon black, RCB, recoverable carbon black. That plant will come online in 2026, and their capacity will be around 35,000 tons of RCB. along with 30,000 tons of byproduct oils, processed oils that can be used. So that'll be a fairly big operation. I think the market will be there for it. So that's the way it's going. It's an exciting project, and it should produce a fairly high quality material, which is really going to dictate the success as a quality.
As long as you brought that up. Boulder is the one that we all are familiar with. They are doing still actively, and they did buy the old one that didn't make it with somebody else, Terre Haute. The other company that just got $170 million is Cirtec, who is going to take about 6% of all the tires in Europe, which is the largest funding mechanism that's ever happened in this. And I can tell you that where the changes that I've seen is the carbon people. When we started our ASTM meetings, it was just RCB guys and trying to make something happen. Now the carbon people are in it, the carbon black, they want it. And it also replaces what they're already doing. And those relationships, Berla Carbon's working with Cirtec. And when you're at ASTM, you get to see all these companies work together. So it's kind of neat. And BP Oil is with Cirtec. So there's more and more movement happening. It's going to happen. And I just want to say, I think, Chris, you said it in the beginning, it is without oxygen when it's being heated up. It's combustion. It is not burning of a tire. So I just want to get that message loud and clear. It is nothing to do with burning a tire. It is coming. So economics, there's money out there. All of a sudden, it's coming for people. So, all right. So we have 15 minutes left. So I'm going to go back, and let's go back and ask another question then. Tire recycling. What do you see as the key challenges to developing new markets in tire recycling? And I'm going to ask you, Eric, because you're out there everywhere. He's in every conference. He's talking here. He's doing that.
So tire recycling, there's quite a few. And so if we look at it from putting tire recycling maybe back into rubber product type applications first, the economics a lot of times are playing into that. So, devulcanized technology has helped a lot in being able to get products where before, if you're just trying to put ground tire into applications, there were restrictions in the performance and the durability that you can achieve. By devulcanizing and refunctionalizing that scrap and being able to put it back in, it opened up a lot of doors. But the issue is right now and how we have the setup of the infrastructure for devulcanized technology and downstream tire waste technology is that you're taking scrap tires and then shipping them to a grinding site, and then it goes from a grinding site to the very few devulcanized technology operations that we have, which most of them are in Canada, and then have to get shipped from there to somewhere else. And by the time you get to the end of the day, you're not cheaper than virgin polymer, which is a restriction. So being able to, instead of trying to hit the home runs of being able to actually take all the scrap tire waste and put them in application, we need more vertical integration through the processes. And I know David's been very successful being able to do those types of things of vertically integrating to be able to be economically viable by the end of the day. So economics is a big component of that. I think the other hurdle that we're up against is just as tires are facing issues from toxicity and sustainability and environmental impacts, that does follow it down through the stream. I know we avoid the topic of 6 ppd being in end-of-life tires. It is. We've tested it. About 50% of the remaining 6 ppd is still there at the end of the life. And it's not that we should be using that as a deterrent to using scrap tire, because at the end of the day, it's not any better for it to be sitting in a landfill leaching out 6 ppd than it is to get into an alternative method. But we should be using that to make wise choices on how we use scrap rubber and maybe even be able to mitigate that issue. Internally, we've done a lot of studies on being able to capture 6 ppd out of ground tire rubber and out of post-lives. And it is very doable and very successful. So I think we need to use it as a way of driving the way we do the technology to be able to mitigate it, because it will come to light at a point, and it's better to be ahead of it.
Good answer. Did you want to say something, David? Otherwise,
I just add that the industry is in its infancy, and like all things, and you talked about it in pyrolysis, it takes time, effort, people, money. And there's just a handful of devulcanization players. We, as Eric said, have taken the vertically integrated approach, which I think is very important to not only have chain of custody of material, but also to take intermediary margins and logistics out of the equation. But capital is a big consideration too. So if anybody's got 170 million for another part of the recycling industry, come see me.
All right, I think we have now about 10 minutes left for questions.
I thank you for a fascinating discussion. I'm excited by all this experience and expertise on the panel. I wanted to ask about a particular chemical, the one I called yesterday, hexamethoxymethylmelamine. Our toxicologist has flagged that for me, and I've been told that it's a tire chemical additive, and I'm just curious if any of you know anything about its use in tires. Is it really used in tires? What's going on? I'm just really interested to learn more about it.
This is HMMM, is that?
Yes.
Yeah, or HMMM. Yes, yeah, that's used in tires. It's a pretty critical component in the rubber to wire adhesion, and it plays a crucial role there. So it basically reinforces the rubber around the wire to maintain the adhesion through the life of the tire.
So in the beads of the tire, the two beads that connect to the wheels, and in the steel belts,
Yeah, the steel ply.
you find it in those compounds.
It forms basically when it reacts, it forms a resin, fairly solid resin, so it increases the tensile strength and so on. It basically maintains that resin condition through the life of the tire, so it doesn't, the molecule HMMM doesn't leach out per se, since it's reacted to form a fairly hard resin.
I have a quick question about the different kinds of natural rubber that you were talking about. And I was just wondering if any of those are less susceptible to ozone degradation and wouldn't need the 6-PVD chemical added.
It's a good question. The backbones, chemically, of all of those are high cis-1,4 polyisoprene. So really, the problem is all the double bonds on the backbone, and that really doesn't change. There are some other subtle differences between those sources in terms of their branching and what's at the chain ends and the molecular weights, but the actual repeating unit that makes up the backbone is nearly identical. So unfortunately, they're all going to have the same kind of weakness that Havea natural rubber has.
We have time for a couple more.
So David Parker, I did a literature search on patents and devulcanization, and then, as you said, there's a lot happening in this field. And I'm wondering, what's your vision for the integrated system or ecosystem of offtake partners for new product development with devulcanization, and how do we build capacity? Obviously, money is a big constraint, but money usually follows profitable offtake partners.
Yeah, I think it's formulating materials that have utility for a number of different end applications, and I think those end applications extend well beyond the substitution of virgin rubber or reclaim rubber. It includes the applications I described previously, asphalt and plastic modification and replacement, certain kinds of plastics. So it's putting in the R&D to have materials that are at the very least a good starting point for the consumer to then be able to interpolate its utility. So having that next step of the formulation work done for different industries, I think, is important. And some of the maturation that's happening in the devulcanization industry. By way of example, we actually devulcanize the material differently depending on what the application is, so that we try to incorporate some of the tweaks that you're going to do downstream in compounding into the devulcanization process. So it's technology advancement, it's having infrastructure that can actually deliver it in an economic form that can scale.
I'll make a quick comment on that too. Like, we've recently done a report on all the devulc techs that are out there. There's 85 patents out there. Devulcanization technology has been out for 30 years now, so it's not a novel concept as being able to break the disulfide bonds. Where the hurdle is functionalizing that to get it to actually work in end systems. So I know it seems like every rubber technical conference, there's somebody rolling out a new devulcanization technology, and I always ask them to stop and refocus their efforts on the functionalization side, because we got, lots of different methods out there right now that work. The breaking the disulfide bonds has been done for years. It's more being able to functionalize it to get it to work in application seems to be the hurdle that we got to cross now to really get that ramp up and scale that we need.
I think is there any others? Oh, one more? Okay.
Yeah, David, I thought I heard you say that we don't do reclaim in the Americas, in the production.
It's not legal to conduct the reclaiming process in North America or Europe, no.
I recognize that there's lots of consumer products coming into this country that are made with reclaimed, and what kind of toxicity issues should we be concerned about with those?
That was on one of the questions we didn't get to, and that is worth every second to give that attention, is we are competing, a lot of our manufacturers of products, with products coming in through Amazon, big box, that are made with chemicals that we, including DEVOC, we cannot make products in the United States using those same chemistries. It is a serious issue, and I hope gets elevated higher up still. Even at ASTM, they just told me in Europe, they're having the same issue. It's not just here, it is everywhere, and it's just going right on by. So if anybody has really good, lots of money and attorneys, and Tim's taken this on, I've been working with him on that issue, but it's a big issue, much
Yeah,
bigger
we
than
have
people are doing. We're done?
I'll just add a practical piece to it, which is, there's a lot of toxicity and there's carcinogens in the reclaiming process, and VOCs and effluents and all sorts of stuff, which is why it's illegal to conduct here, but apparently somehow the product still containing that material comes into the US. Just a practical tip: if a rubber product that you buy has got sort of a greasy texture to it, or is green, and that color comes off on your thumbs, that's a telltale sign it's been made from rubber reclaim, and it'll smell.
My name is Angel Mateos with the University of California Pavement Research Center. I have one comment and one question. The comment is related to the devulcanized rubber. When it comes to asphalt pavements, the main challenge from my point of view is going to be the energy, right? The asphalt industry is trying to move in a direction where the greenhouse gases emissions from the mix is very low. So the challenge is going to be how to add the devulcanized rubber without increasing the greenhouse gases emission. That's, from my point of view, the main challenge. And then I have a question related to the difference between regular tires that have a natural rubber content lower than the truck tires that have a higher natural rubber content. So when it comes to asphalt pavements, we use basically two different ground rubber modifiers product. One of the product is the regular, mainly comes from tires, from car tires. The other has a higher content of natural rubber. Would you expect big mechanical differences between the two products? Again, one of them that is called the high natural, that has at least 40% natural rubber, compared to the other one that comes mainly from regular car tires.
So this is one of the reasons that asphalt is a very interesting end application for end-of-life tires that are subsequently devulcanized. SBR, which is one of the predominant alternate polymers, as you know, to natural rubber and polybutadiene in a tire, is a close cousin of SBS, which is the most prevalent polymer used in the modification of asphalt. So when you start with a passenger car tire rather than a truck tire, you're actually starting with a better tire, with a better starting material. Now, we've done a lot of testing with both, and the differences are pretty negligible, but actually there's no issue related to passenger car tires. From a chemistry perspective, it's beneficial. From a practical perspective, it's just important to not have textile contamination, and that's a reason that some people prefer truck tires, is the absence of textile and the assurance that there's no textile. But as long as the passenger car tires are properly granulated, and then downstream from that, there are additional cleanup that happens, the passenger car tire is actually a better starting point.
Well, I want to thank all of you for all the time and effort you put into this with me too. So, and thank you for presenting today. So, thank you.
Thank you, everybody, for that. I feel like we could have talked about that for at least another half hour. So I would encourage, if people have questions, if you guys are available to answer those throughout the rest of the conference, that'd be great. Super interesting panel.